Good morning, students. How are you? Right. Are preparing well? I think so. Right. See, we will be discussing in today's class the continuation of the mole concept. In the last few classes, we have been discussing about this mole concept. That mole concept part 6. That mole concept. Sixth part today I am going to discuss that. Okay. Please try to understand. I will be explaining slowly and systematically. In the last class we were discussing about this some of the methods of expressing the concentration of solution. These methods I have named molarity, mole fraction and so on. We have discussed about the molarity in the last class, I think you remember. We have discussed various conditions when molarity is given. But sometimes I would like to discuss the next methods also, that is molarity and mole fraction. Before going to that, sometimes they will use one word in place of molarity, that is I would like to explain about formality. Suppose anywhere you come across this word formality which is denoted by F, don't confuse here, because this is generally used for ionic compounds to express the concentration of the solution containing the ionic compounds there. Why? Because let us take up the sodium chloride. Sodium chloride contains, what are the structural units present in sodium chloride? It contains Na plus ions, right, and Cl minus ions. So only ions will be present in an ionic compound, no atoms and no molecules will be present there. That is why I cannot call it as a molecule. It is not a molecule. It is not molecule. What is a molecule there? Suppose you take carbon dioxide there, I can call it as a molecule there. It is a molecule. It is a molecule. You see the difference, that when you are writing the molecule, it will exactly represent the number of atoms of different elements present in each molecule like this. One carbon atom, two oxygen atoms are present. But this sodium chloride is not indicating the exact number of ions present in the sodium chloride crystal. What it is representing then? It is representing only the empirical ratio between the Na plus and Cl minus ions. It is telling you that equal number of, or 1:1 ratio of Na plus and Cl minus ions are present in this crystal. That's all it is giving information there. So such type of formulae are called as the formula units. It is not a molecule, but it is a formula unit. It should be called as it is a formula unit. I hope that you understood the difference between a formula unit and a molecule there, or molecular formula. This is molecular formula. It is not the molecular formula. It should be called as formula unit, right? The weight of the formula unit, is called as, formula weight. The weight of formula units is called as formula weight. I will write here that the weight of one formula unit, the weight of one formula unit, is called as formula weight. Right? This is a very important word I am using here, that instead of molecular weight, we are using the formula weight of ionic compounds, where it is called as formula weight. This formula weight is equal to 1 mole, for ionic compounds. Right. So what we have discussed about the molarity is equal to number of moles of solute by volume of the solution, in liters we have discussed here. Now I am comparing this molarity with the new parameter, that is formality. Similarly, the formality is equal to number of formula units, the number of formula weights. Why? Because 1 mole of an ionic compound is equal to its formula weight there. Number of formula weights by volume in liter can take. This is called formality. So formality can be defined as the number of formula weights of an ionic compound present in 1 liter of the solution is called as formality. Why we can define like this? Because for ionic compound 1 mole is equal to its formula weight there. But sometimes in case of formality also they are giving molarities there. But specifically they may give formality also there. You should not confuse there. So formality I will define as the number of formula weights. Number of formula weights of an ionic compound. Present in 1 liter of solution. Is called as formality. Okay. Now we have discussed what is formality and how they will give formality in case of ionic compounds and how it is different from the molarity we have discussed there. Okay. What we have learned about formality? Formality is nothing but equal to molarity, but specifically it is used for the ionic compounds, since ionic compounds do not contain molecules, instead they contain formula units there. The next one I am going to discuss is the next expression of concentration, that is molality. This is called molalities. This is denoted small m. Remember, the molarity is expressed or denoted by capital M, but molality is expressed by the small m. What is the definition of this molality? It is also dependent on the number of moles. The number of moles, the definition is like this. The number of moles of a solute, present in 1000 grams of solvent, is called as molality. Here I am underlining this 1000 grams here, because just like in the molarity we are taking specifically a fixed volume. In that 1 liter of the volume, whatever numbers are present, that I am calling as a molarity. In the same manner, in case of molality, the fixed parameter is 1000 grams of the solvent there. That was a volume, but this is the weight, remember that. And what is the importance of molality? Actually, what is the need of molality when we have already one method, that is molarity there? It is because molarity is temperature dependent, because volume term is involved in that. But molality is temperature independent, because no volume term is involved here. That this is constant parameter. 1000 grams of solvent should be taken every times when we are expressing the molality. Right? One thing let me tell you here, that molality. What is the requirement of molality here? How it is more important than the molarity? That is, molality is temperature independent. It is temperature independent. It is temperature independent. It is not dependent on the temperature, you remember, right? Now, and one more important point here, that how to express molality. It is called 1 molal solution. 1 molal solution is always expressed like this, 1m. Okay. Then what are the units of this 1m there? Moles per kilogram. This is the number of moles per kilogram is giving you the molal solution, that 1 mole per kilogram. So what are the units of the molality? The units of molality is always equal to moles per kilogram. Okay. These are the units of the molality there. Now it is very simple that how to find out the molality of a solution there. Again, let us take a simple example that I am taking up one solution there, right? The weight of the solvent I am using here, that the weight of the solvent is, suppose, 1 kilogram of solvent I am taking up here, that it is rather saying that the number of moles present in 1 kilogram of the solvent, which is better or more appropriate to say that the number of moles of the solute associated with the 1 kilogram of the solvent, that will be more appropriate here, that 1 kilogram of solvent is present here and it is now associated with the 1 mole of solute, suppose 1 mole of solute. Then 1 mole of solute is present in 1 kilogram of solvent also, I can say. Then what is the molality of this solution there? It is nothing but 1 mole per kilogram. Then I can call it as the 1 molal solution. 1 molal solution. 1 molal solution. The simple representation of this 1 molal solution is 1m. I will write like this. Okay. Now I will make a small difference in this. One more vessel I am taking here, that containing the same 1 kilogram of the solvent here. 1 kilogram of solvent. Right. It's very simple that if I am taking up the 2 moles of solute, 2 moles of solute, then what would be the molality of this solution there? Now you can easily answer here that this is 2 moles per kilogram. Then I will take it as the 2m solution there. Okay. Now let us change the volume of the solution here, that see, whatever may be the volume, we are always calculating the molality per 1 kilogram of the solvent only. Here I am taking up, suppose 1 mole of solute I am taking there. 1 mole of solute I am taking, which is dissolved in the 500 grams only. I will take 500 grams of solvent. Okay, what is existing here? 1 mole is present in the 500 grams of solvent. 500 grams of solvent. Then 1000 grams of solvent will contain how many moles? Because always molality indicates the number of moles present in the 1000 grams of the solvent. That 5000 by 500, this will give you 2m solution. So it is a 2 molar solution. It is a 2 molar solution. Let us generalize this, that in another example I will take up that n moles of solute I am taking up here, right, which is dissolved in the let us take that w grams, something w grams of solvent. Okay. Now N moles are present. N moles are present in how much weight? That is W grams of solvent. Then in 1000 grams of solvent, how many number of moles are present? That is what we are calling as the molality, isn't it? Now, 1000 into N by W. This is giving you molality. So molality is nothing but number of moles present in 1000 grams of the solvent there. Can I write the number of moles like this? I am writing the number of moles like this. Weight of solute by gram molecular weight of solute. Okay. Now this is 1000 by W, which is nothing but the weight of the solvent there. Now like this, we can find out the molality of any given solution using this simple formula here. So let us do a very simple problem to understand this formula here. That problem number 1 today, let us see. Are you listening or not? Concentrate on this, right? Problem 1, look at this problem. 2 grams of sodium hydroxide is present in 100 grams of solvent, suppose. 100 grams of solvent. Find the molality of solution. This is the question. Then what is the solution of this one? Let us see. Here 2 grams of sodium hydroxide is given there. Find out the number of moles of hydroxide. How do you get the number of moles of the sodium hydroxide here? The weight given to us 2 grams, its molecular weight is 40. Then it is equal to 1 by 20. 1 by 20 is equal to 0.05 moles. This many moles are present there. Number of moles of sodium hydroxide there. Then if you want to find out the molality of a solution, then molality is equal to how many number of moles are there? 0.05 moles of solute is present. And what is the weight of the solvent? That is 100, and I am expressing this in the kilograms. This is giving you 0.5 molal solution. The answer is 0.5 molal. It should be pronounced as a molal solution, but while you are writing, the symbol small m should be given here. Okay. Now one more problem, let us see that. Problem number 2. You see the problem is like this. Find the molality of 20% is giving weight percent, W by W, symbol is right. 20%, find the molality of 20% by weight sodium hydroxide solution is given, suppose. Sodium hydroxide solution. He has given here weight percentage. What is the meaning of this? Okay, let us take up the solution for this, that is. What is the meaning of this 20% W by W? Come on, tell me. You know, already we have studied. It means that 20 grams of solute is present in 100 grams of solution. 100 grams of solution. This is the meaning of this, right? Now, 20 grams of solute is present in 100 grams of the solution here. Then, what is the weight of solvent here? The weight of solvent will be equal to weight of solution. What is the weight of the solution? This is the weight of the solution, 100. And what is the weight of the solute? That is 20. This is giving you 80 grams. 80 grams is the weight of the solvent, right? Now we got weight of the solute as well as weight of the solvent there. Now let us find out the number of moles of sodium hydroxide. That is by dividing this 20 grams with 40, you will get here that by 2. 1 by 2 is equal to 0.5 you are getting. 1 by 2 is 1 by 2 is equal to 0.5. Then the molality is equal to 0.5 by 80. I am converting this 80 into kilograms there. Then what I would get is that molality is equal to 0.5. Rather it should be 500 by 80, isn't it? 500 by 80, the 0 gets cancelled. 50 by 8 I am getting here, 50 by 8. Okay. Now 8 5 ja 8 6 ja 48, 2 8 2 ja 6.25 m. This is the molality of the solution, the answer. Okay. Now can we generalize, after looking into this problem, that can we generalize when weight percentage is given there? Suppose a solution is present, it is having the X percentage W by W, nothing is given there. Then we want to find out what is the molality of that solution there. Okay. Now you see that as we have done in the previous problem, that weight of solute, how we have calculated here, weight of solute is equal to X grams. Then weight of solution, what is the weight of solution in this case? That will be equal to 100 grams there. Okay, that will be equal to 100 grams. Then weight of solvent is equal to how much? Weight of solvent will be equal to 100 minus X grams we are getting. Now we know the weight of solvent and we know the weight of the solute. Now we have to find out the molality there. Then molality is equal to, how do you get? X by gram molecular weight of the solute. Gram molecular weight of solute into, this is 1000 by 100 minus X, because this is the weight of the solvent there. So we can create a formula directly to get the molality from the weight percentage there. Whenever weight percentage is given there, the weight of the solute is X and weight of the solvent is 100 minus X. It's very, very simple. Okay. Now we'll discuss more about this molality. Now some problems they will give you, they'll give you molality and ask you to calculate the molarity then. Why? It is because for a same solution we can express its concentration in different methods, maybe expressed in molarity, maybe expressed in molality, depending on the requirement then. Now here one more parameter I am discussing here, that is relation between molality and molarity. Molality and molarity. What I am trying to establish here is the relationship between the small m and capital M. Okay. What is that? Let us see. There is a solution is given to us. Okay. Here, imagine that the molarity is given here. Molarity is given that X molar solution. It is a X molar solution there. And its density is also given there. The density of the solution is equal to, imagine that density of the solution is D something. The units will be grams per ml. Let us take grams per ml there. Grams per milliliter I am taking up here. Now he is asking that what is the molality of this particular solution there. For a same solution, molarity is given and the density is given, and asking that what is the molality of this solution there. Okay. Now this x molar solution indicates what? X molar solution means x moles are present in 1 liter of solution. 1 liter solution, isn't it? X moles are present in 1 liter of the solution, then it is called as the x molar solution there. Okay. Number of moles we have come to know here. We need not to find out any number of moles. Directly we know that is x moles are present in 1 liter of the solution there. Now only thing is that we need to find out weight of the solvent there. Okay. Weight of solvent, how I get there? Before going to get the weight of solvent, I should get the weight of solution. How? See, the density is indicating that 1 ml is weighing d grams. 1 ml is weighing d grams. Okay. Then 1 liter means 1000 ml will have how much of weight? That is equal to 1000 into d. This is the weight of the solution there. Clear or not? Very simple. Okay. By using the density parameter, I am finding the total weight of the solution here. Okay. Now I want weight of solvent. Weight of solvent I want. Weight of solvent is equal to, how I get? Weight of solution minus weight of solute. This is the weight of the solution. What is the weight of the solute? Here the problem, what is the weight of the solute there? Okay, that also we can find out here. How? You see, the number of moles of solute we know, how much? X moles are present there. Then I can get that weight of solute is equal to number of moles into its gram molecular weight. We know already how to get the weight from the number of moles there. So here I am writing that x into gram molecular weight. X into gram molecular weight. This is the weight of the solution and this is the weight of the solution, and the difference between them is giving you weight of solvent there. Okay. Now I'll come to the basic formula to calculate the molality. What is that? Molality is equal to number of moles of solute by weight of solvent. Weight of solvent in what units? Weight of solvent in kilograms we should get. This is a basic formula, already we have seen. Now number of moles of the solute, what we have seen? X by, then what is the weight of the solvent there? Weight of the solvent here we have calculated, that is 1000 into d minus x into gram molecular weight. This is the gram molecular weight of the solvent, but it should be in kilograms. That is why I am dividing with 10. So whenever molarity is given there, for convenience sake I will do one thing, that in place of the x can I take the molarity directly there. I am more generalizing this. M is equal to capital M, whatever molarity is given to you, 1000 d minus x. X means I should take here that again molecular weight into gram molecular weight, and this should be multiplied with 1000. Okay, this is giving you the molality from the molarity there. This is giving you molality from the, okay. Now suppose, how to get the molarity from the molality there? Let us see in this case that, one more case, the reverse of this. Analyze these things. Now here x m is given, x molal solution is present there. Again the density of the solution is given, something density is in grams per cc is given. Now he is asking that for the same solution what is the molarity is asking there. Okay. Now the reverse calculation here. We need the volume of the solution now, not the weight of the solvent there. Okay, but number of moles of solute, no. Number of moles of solute. Number of moles of solute is equal to X, already we know. Okay. Now, volume of the solution is required here. That is the only requirement, is volume of solution is required. Volume of solution is equal to how much? How to get the volume of the solution? Look at this, that what is this relation is telling you, that 1 cc is equal to d grams. 1 cc is equal to d grams. 1 cc is having a weight of d grams there. But how much weight of the solution we have? How much volume of the solution we need here, right? What is the volume of the solution? We want to know here that d grams is equal to 1 cc. Then what is the total weight of the solution here? What would be the total weight of the solution there? I want that 1000 cc should be taken to define the molarity. Already you know that for 1000 cc what is the weight of the solution there. What is the weight of the solution there? D grams is equal to 1 cc. Then rather I want the volume of the solution here, right? For 1000 cc, how much weight that would be giving you total weight of the solution there. So better I will find out that what is the total weight of the solution there. What would be the total weight of the solution there? Okay. We know that always it is equal to, total weight of the solution is equal to 1000 into, 1000 is, that is the weight of the solvent there. Then what I should take here? Plus X into gram molecular weight. This is the total weight of the solution. This is the weight of the solvent and this is the weight of the solute. Okay, X into number of moles into its gram molecular weight. This will give you how much? This is giving you 1000 plus X into gram molecular weight, X into gram molecular weight by D. This is giving you total volume of the solution. Okay. In what units it is there? In milliliters. Okay, I'll write here milliliters also. Let us use the basic formula to calculate the molarity. Molarity is equal to number of moles of solute by volume of the solution. Volume of solution in liters. Okay, but here the value is in milliliters. That is why I can write here that number of moles of solute by volume in milliliters. If you are taking, you should multiply this with the 1000. Okay, now take up this value, which is the volume of the solution here, that number of, how much it is given, m is equal to small m, then that is 1000 plus, here in place of x I will take small m into gram molecular weight, into gram molecular weight. This d comes to here, okay, and into 1000. We can get the molarity from whenever molality is given by using this expression there. This is the outcome of our analysis here. Okay, this is number of moles of the solute there. This is total volume of the solution in liters there. Okay, like this we can get the molarity from the molality and molality from the molality. Okay, now we will do some problems so that we can understand how to convert the molarity into molarity there. Okay, now take up some problems here, that is try to solve simultaneously. In today's class, let us take this is problem number 3. Okay, what is that problem? Let us see. Find the molality of a solution. Molality of 2 molar solution, 2m solution, whose density is equal to 1.2 gram per cc. Okay, this is what given. What is the solution of this problem? We will discuss here, right? What is the molarity here? The molarity given to us is equal to 2m. What is the meaning of this? The meaning of this is that 2 moles of solute present in 2 moles of solute in 1 liter of solution. This is the meaning of the 2 molar solution. Okay. 2 moles of solute is present in 1 liter of the solution then. Okay. Now let us find out that number of moles of solute is known. How much that is? 2. Now we want that what is weight of solution? What is the weight of solution here? What is the weight of solution? How do you get that? Density is used for this. What is the density there? 1.2 grams per cc there. It means that 1 cc is equal to 1 cc is weighing how much? 1.2 grams. Then here 100 cc or 100 ml is equal to how much weight? Now upon calculation this will be equal to 1 to 1200 grams we are getting that. This is the weight of the solution. Okay. Now from this can we get that what is the weight of solvent? Weight of solvent is equal to 1200 minus what is the weight of the solute here? That is 2 into so what is the solution? Nature of the solution is given 2 molar. Let us take it as the 2 molar NaOH solution. 2 molar NaOH solution. Okay. Now 2 into molecular weight of that one is equal to 40. Molecular weight of sodium hydroxide is equal to 40. I am taking up here. This is equal to 1200 minus 80. 1200 minus 80 will give you 1100. 80 if you subtract here that 1120 will get. Okay, 1120 grams. Now let us substitute this in the formula to calculate the molality. Molality is equal to number of moles are given how much? 2 by this is 1120 into 1000. This is giving you 200 by 112 is equal to, this will give you something about 1 point that is equal to 88 means 1.7 approximately molar solution we are getting here. Okay, like this we can get the molality from the molarity. Directly we can use the formula, otherwise we can analyze the things also like this to get the molality from the molarity. Okay, see the relationship between molality and molarity depends on the density there. It depends on the density. Is there any condition where molality is exactly equal to molarity? Is there any condition? At what conditions? We discussed that. At what conditions molarity of a solution is equal to molality. Now if you look at the relationship between this, molarity is equal to m into 1000 d minus and the gram molecular weight into m. We have seen this relationship there. We want that this m should be equal to this m there. Then what should happen here, that exactly this difference should be equal to 1000. Then this 1000 gets cancelled, that this difference should be equal to 1000. Okay, now can I write like this, that to get this relation is equal to 1000, 1000 d minus gram molecular weight into m should be equal to 1000. Okay, now this is 1000 d is equal to 1000 m into gram molecular weight. Okay, now the density should be equal to how much I am getting, that 1000 plus m into gram molecular weight by 1000. This can be written that 1 plus m into gram molecular weight by 1000. Suppose for any solution the density is satisfying this condition, at these conditions whenever the density is equal to 1 plus molecular weight into gram molecular weight of that divided by 1000 is exactly will give you same. At this density for a solution I give you that molality is equal to molarity. Suppose imagine that for the solution of density of sodium hydroxide solution, let us take up what it would be, 1 plus molarity. Imagine that let us take 1 molar solution there. For example, let us take up for example that molarity is equal to 1. Okay, 1 into 40 by 1000. This should be equal to 1 plus 0.040. Then this will be giving you 1.04 grams per cc. When you take this much of density, that we can say that molality of that solution is also will be 1. You substitute and try to find out the molality there. So the condition I am giving you that a solution will have same molality and molarity whenever its density is satisfying this relationship there. Okay, in the next class I am going to discuss about the mole fraction and how it can be interrelated with the molality and molarity. We will discuss there. Okay, thank you.